Understand the basic DMVPN, this is the configuration we will be doing on the hub router. So let me just quickly explain. We need to, in order to build a point-to-multipoint tunnel on all the routers, so starting with the hub router, so we need to create one tunnel interface. So tunnel is a logical interface we can create. You can use any number like 0, 1, 2, 3. So not compulsory to match, locally significant. And we'll be giving some tunnel IP address. So the tunnel network I'll be using 10.network. So I'll be using 10.network with /24 subnet mask. So which means I'll be using 1 here, 2 here, 3 here, 4 here. So 10.002, 10.003 and 10.004. So that is a private IP or the tunnel interface IP address what I'm using here. Now there are two commands as I explained. These two commands defines the multipoint GRE configuration. So we have to mention what is the tunnel source, where the tunnel starts. So if I'm doing it on the router 1, the tunnel starts here. So the tunnel source, either I can define the interface name, or even instead of interface name I can also define the interface IP address also. But again, if you're using dynamic IP, then basically you cannot mention the IP address because that may change. So it is again recommended to define the interface name. But as already explained, on the hub you must have a static IP compulsory, but on the spokes we can still have a dynamic IPs. So even if the IP changes on the spokes, still that's not going to impact the DMVPN tunnels. So the tunnel source we need to specify, and instead of tunnel destination we have to specify this multipoint GRE tunnel, which means I'm saying this tunnel, I'm treating only one tunnel, that is tunnel 0, and this tunnel will have multiple endpoints. So how many? 3, 4, 100, it can be any number. So this is your multipoint GRE configuration. The two commands enables the multipoint GRE tunnel. And the next thing we have something called IP NHRP network ID command. So basically this command is going to enable the NHRP on that tunnel interface. Because if you don't enable, then basically NHRP is not going to work. Okay, so the basic purpose of this NHRP is to enable the NHRP on the tunnel interface. And again, it is actually used to define the NHRP domain on that particular interface. Okay, so basically this is also used in advanced scenarios. Let's say if you have a tunnel, so if you have multiple tunnels, let's say basically to differentiate two different tunnel domains, you can use two different NHRP IDs. So it's a kind of advanced scenarios where you can have we can have a multiple different domains on the same tunnels. Basically you can still use that NHRP network ID command. And make sure that this NHRP network ID command is a locally significant value, which means it's not compulsory that on the remote routers it has to match. So basically this NHRP network ID is not transmitted in the NHRP messages. So that's why it can be different. Like you can use NHRP network ID 1 here, 2 here, 3 here, 4 here, still you know it doesn't really impact. Best practice, if you want to go with the same value, it's up to you, but basically this is not compulsory to match. It's a locally significant value and it is not transmitted in your NHRP packets. Okay, so this is the minimum configuration you need to add. I'll just come to this. What is this command? NHRP map multicast dynamic command. This is for routing. So in order to build a tunnel, this is a minimum configuration you have to do on the hub router. So if you move on with the spokes configuration, like on the router 2, router 3, router 4, so the commands up to here remains the same, no difference. We need to create a tunnel. So tunnel number can be different. So again, the tunnel number also is a locally significant interface. And the IP address on the router 2, it is 2, 3, 4. Just change the IPs. So I'm just using X here. X represents the router number, 2, 3 or 4. And the same command, tunnel source. So the source interface I'm using same in all the interfaces. So basically it's the same here. and then enable the NHRP by using NHRP network ID command. So the configuration part up to here is still the same. Now there are two additional commands we need to add on the spokes router. So NHRP, there is a command called NHRP next hop server. So the router 2, if you remember, I discussed the spokes has to send out a register messages to the hub in order to register themselves and tell what is the tunnel IP address, what is the public IP, and what is the tunnel IP address they are using. So in order to send out the register messages, the spokes should know who is the server, who is the next hop server. And that's what we are trying to do here. So this command is not required on the hub because hub itself is a next hop server. So basically this command is only required on the spokes, where we are going to tell that who is your next hop server. I'm saying the next hop server is 10.001. That is the tunnel IP address. And we also need to tell, in order to reach that 10.001, what is the public IP. So what is the public IP I'm using on the server? 15.001. And that's what the next command here. If you see here, we are saying IP NHRP map. To reach that 10.001, you have to go with the public IP of 15.001. So which means, because as per the part of configurations, you cannot directly tell the public IP here. So the first we have to tell what is your next hop server, and to reach the next hop server, what is the public IP. So these are the two additional commands you will find on the spokes compulsory. Okay, so additionally you can still configure these commands. I'll just come back to these commands in the routing part. So the first thing I just want to set up the tunnels and verify between these sites. So let's go ahead and do the configuration here. So I'll start with the router 1, the hub router. So we create one tunnel interface and then the IP address like 10.001, any private IP you can use, and the tunnel source I'm going to use S2/0, that is the exit interface on the router 1, and tunnel mode GRE multipoint. So I'll be using GRE multipoint tunnel. So this is the same configuration you'll find in all the routers. And additionally, we have to enable the NHRP. Use any number. So I just prefer 1 in all the cases. So if I just go to the router 2, so if I try to verify my configurations here, so these are the configuration commands. What you'll find on the router 1. Okay. So tunnel source commands and NHRP. So basically on the router 2 also we can use the same commands. The only thing is I need to change the IP address to router 2. Of course the interface is same on the router 2. And enable the NHRP, we can use same or different numbers, it's up to you. So additionally we have to say IP NHRP next hop server. What is my next hop server? 10.1. And we have to say IP NHRP map. What is the, so again you also use question mark. So basically let me write down this 10.0 to reach this 10.001, the public IP. Okay, so let's go to router 2. I'll try to copy paste these commands on the router 2. So let's go and create the tunnel interface. Okay, so we'll say IP NHRP next hop server. So if you use question mark, you can see what is the IP address of the next hop server, 10.001. And then we have to say map, what is the IP address of the destination, that is 10.001, and what is the NBMA address. NBMA is nothing but your public address, so 15.001. So I think the commands are correct. So done. So the same thing we need to do on the router 3. The router 3 we just need to change the IP. Rest of the things remains the same, no need to make any changes. So I can copy paste the same configs on the router 3. On the router 4 we need to change the IP. For network ID we can change or not, it's up to you. On the router 4 as well I need to go and to this configuration. So you can see the tunnel configuration is very simple. Even if you have hundreds of sites, you may end up doing the configuration approximately 5 to 6 commands. So not more than that. So once we are done with the configurations, if I say show IP interface brief, we should see the tunnel interface should be up. Let's go and verify from the router 1. So on the router 1, I'll say show IP interface brief. I can see the tunnel interface is up. So which means now, as per my scenario here, we must have a tunnel interface ready between them, and the IP address I'm using 10.network, and I should be able to reach the other side. If I say ping to 10.002, that is the IP what I'm using here. So let me just write down the IPs here. So I'm using 10.001 here, and 10.002, 10.003 and 10.004 here. Okay, so we got the tunnel interface established between these 3 sites here. So if I go and ping to the router 1 to 2, I should be able to ping. So even if I try to ping to the interfaces, I do have reachability. So if I try to say show DMVPN, you can see show DMVPN will show you the DMVPN tunnels. So I do have a peer. So I have peers, these are the spokes. And these spokes, these are the tunnel IP addresses, and they're dynamically built because the spokes have sent the register messages, and these are dynamically built and it is up. So similar way, you can use a command called show IP NHRP detail. That's another command to verify. Here also you can see the same thing. So these are the tunnel IP addresses, and the tunnel is created, tunnel 0, and dynamically with a NBMA address, these are the public IP addresses. If I go and check the same thing from the router 2, if I say show DMVPN, now on the router 2 we do have only one peer. We do have only one peer here, which is this one, the router 1, 15.001. So just see the last portion. The last portion represents the router number. That's how you can easily recollect which router it is pointing to. And it is manually built because we have configured the map statement, if you remember, based on that. So what I'll do is I'll try to see if, because I'm using Multipoint GRE here, which means we should have a tunnel established from here to here already with a static. And also, once I initiate the traffic, I should see the tunnels will be dynamically established between spoke to spoke. If you remember, I discussed that a full mesh tunnels can be built dynamically. That's what dynamic multipoint VPN. So for this, we need to initiate the traffic. So I'm going to say trace. I can also use ping, but trace will give you a good option. I'll try to trace to 10.003. So initially, if I try to trace, the traffic flow goes through 1 and 3. It goes like this initially. And if I try to trace once again, I should see the trace goes directly. And if I say show DMVPN, you can see there is a DMVPN tunnel established between router 2 to router 3. So this is like whenever a spoke wants to communicate or try to reach 10.003, initially the router 2 don't know, so it is going to ask. So the initial flow will go like this. If you remember the NHRP messages, resolution request messages. And after that, it is going to build a tunnel. If it is a multipoint GRE, then basically it will go directly after that. So you can use the trace command to just confirm that. Similar way, you can do the same thing for 2 to 4. 2 to 4. So first it will go like this, and next it should go like directly. Let's trace. You can see. And now if you check show DMVPN, so once we initiate a traffic, there will be a dynamically full mesh tunnels established between all the sites. And you can see these tunnels are built dynamically. So similar way, if you check on the router 3, you have a tunnel between 2 to 3 and 3 to 1. From router 3, we have 1 and 2, but we don't have between 2 and 4, 3 and 4 because we didn't initiate any traffic between them. So once we initiate a traffic between them, you will have a tunnel established between them. So show DMVPN, you can see there is a dynamic tunnel established between 3 and 4.